Now for the C, which stands for control, circuitry, and a little concealment. And what I mean by concealment, just to get it out of the way, is how do we hide our wiring pathways. If we're doing something in the ceilings, it's not really about concealment because it's already hidden, but it specifically refers to cabinetry, any intricate details, how the wiring needs to hide or be integrated into the structures so that we have a good wiring entry point into that small linear detail. So let's start at control. Control could be categorized in remotely, which could be physical switches away from the device, like a wall switch, or it can be done wirelessly, remotely, which is a remote control device that controls the LED from a distance. So when I say remotely, I mean the device is not at the light source like a motion sensor. I'm talking about physical wall switches, physical dimmer switches, physical remotes that use a wireless protocol to control the light remotely. When I talk about local controls, I'm talking about PIR sensors, I'm talking about motion sensors, a localized bell switch or some sort of switch that's close to the light. So that's how we categorize it, because we either trigger the action at the light source, which may have an embedded touch switch, for example, or we trigger the action remotely from a wall, from a wireless device, from a tablet, from automation. So we need to discover how are we going to control this light. And this becomes such a problem in a lot of residential jobs we've done where the electricians drop a wire and they forget they have to tie it back in to a wall switch because they're so accustomed to the old lighting systems that had a switch locally or underneath the cabinetry, and we have to implement some sort of wireless device and stick a remote onto the wall, or even cut the wall to the nearest socket and retrofit that socket into a switch and socket combo. So you use a half switch with a socket and you could use that combination. I could probably share a picture in one of the kitchens you'll see later on in the course. This was done where the switch is localized and the transformers are located remotely. The other part of control is you want to think about the compatibility of your controls at this point. So if you have first of all, you have to ensure that you have a dimmable LED, and from that dimmable LED, you want to ensure that your power supply or a transformer is dimmable, and you want to ensure that your dimmer switch is compatible with the dimming protocol of your power supply. So if you have a triac dimmer that's using reverse or forward phase type dimming, you want to ensure that you have the most compatible dimmer switch that works well with it. If you're using 0 to 10 or 1 to 10 dimming, you want to ensure that your dimmer is compatible. Usually wireless controls are compatible with LEDs once the LED has the ability to dim. Please refer to the example I shared with not all LEDs could dim. Remote controls are usually compatible because the controls come with the receiver and the manufacturers make them to be in sync. And the same goes for any sort of automation. You want to ensure that the protocol being used in any automation devices are compatible with the power supplies you are using. And in the case of DALI systems, DMX systems, you have to ensure that compatibility is there with the light source that you're using. So that's the main way to control an LED. I'm just gonna briefly mention about DALI dimming systems in a document, but it's not important for this course. I'm just gonna mention all the dimming systems on a document so you could read up on it some more and get familiar with how they're laid out in terms of the control aspect. But always be sure to plan that control point. The second thing is circuitry. And this is where we need to spend a little time. I'm actually going to get on the iPad and run through a few examples of circuitry. Circuitry is really where we're putting our power supply, ensuring that there's a control wire or control mechanism so we know how we're switching on and off our power supply or on and off our LEDs. Because with the control sides, we switch the LED off at the low voltage side. After you identify where your power supply is being placed, and at this point I should tell you, power supplies, I'm going to say it again, power supplies need to be placed in a cool, ventilated space, not taking any excessive heat. If it's taking any excessive heat, as we identified in the A application, we need to do some sort of trick to ensure that we counterbalance the operational temperature of the power supply and the environmental temperature where it's being placed. So you want to store it ideally in a cool, ventilated space. You want to ensure that it is accessible. We have seen power supplies get sealed up in ceilings. We've seen power supplies get sealed within gypsum. I know some of you guys are having a good laugh, but if you're working with people who are unfamiliar about basic practices, it could happen. I've seen it happen in different countries. It happens. It's very rare in certain instances in certain countries, but the possibility still lies there. The next aspect you want to look at is your wiring pathways. How many parallel circuits are we running? How many series circuits are we running? And this all boils down to the maximum serial connection of the LED, the wiring pathways that are joining the LEDs, and the need for parallel connections, that we have voltage drop on the light not maxing out the maximum serial connection distance of your LED linear light. The two ways, I'm just going to mention it here. You could either do pigtailing, which is connecting light to light, light to wire to light, light to wire to light, or you can do a bunch of home runs where you connect a light back to the power supplies, another light back to the power supply, another light, and back to the power supply. And what we do in these cases, we create little tables and we label the lights. So we would label a light L1, for example. And if that light had another light in the series attached to it in series, we would say that's L1A, and then there's a wire, and then it connects to L1B, and then there's a wire, and it connects to L1C. If there's another parallel run in a small system, we would now say this is L2, because it's the next home run off the power supply. We would say this is L2A or L2B, or just simply L2 if it's only one light. So we create a small labeling system and tagging system to ensure that other contractors could work in the space, and if things get shifted around or moved around, we have a way to identify our cables. So what we would usually do is either take a plan that's given by an architect or an interior designer, or we take a picture at a house that doesn't have plans and we're doing a small detailed closet or cabinet or cove ceiling, and we would make a map. And this map, we complete this map in engineering. So we have a source document so we can maintain the products in the future if anything goes wrong. And things do go wrong. Even though we have reliable installations, there are hiccups that can happen. It could be manufactured defects. It could be somebody who's cleaning and ripped out a wire and they need you to come service it. It could be the power supply just simply failed, which really happens sometimes. But you want to have this source document so you could always refer to it in the future if you have to do any sort of correction. And that source document is really going to serve in our troubleshooting module, where you could refer to it to figure out what you did, what was done in the first instance, and what you have to correct. Also in the circuitry, because we spent a lot of time of wiring, this is where you decide your wire gauges, how you get an idea of what kind of wires we need to place, and we finalize that. You can make inferences, but you get that solid confirmation when you enter the E part, which we'll mention later on. In circuitry, always be mindful of your power supply, the amount of home runs or the amount of series runs you're going to use when you look at the application. Just to recap on circuitry, we look at one, the power supply replacement. We understand how we're going to turn that power supply on and off for the LED. Two, we're going to look at the best pathways to run our system, whether it's series or whether it's parallel. Three, we're going to have a small consideration of wire gauge and how we could bring thicker wires and distribute smaller wires, for example, if that's a strategy. Four, we're going to look at the most concealed ways to hide this wiring. And this becomes relevant in small projects like a kitchen or a closet, and it's a retrofit. And I could tell you, even though a lot of closet companies are supplying LED lights, we have repaired LED lights for imported Italian, imported Turkish closets. We have replaced lights, because my take is, and I tell people that come to me, closet people are not lighting specialists. the closet people. They're just integrating lights, or maybe they should partner with a lighting company. But we've corrected lights, we've increased output, we have moved lights, we have removed sensors from automated closet lights to help the client get something that's just on and off and they didn't like the feature. So we've done a lot of after work on we've done a lot of modification work in that industry, and wire concealment is always an issue, especially if it's a locally done cabinet that you have to put your lighting details after the fact it's installed. Concealment of wire is key, and it's going to ensure that that installation looks really professional and neat. I've seen some things on YouTube and other installers doing, and they're just taking hot glue and dumping hot glue all over the place, and it looks crazy and looks very unprofessional and untidy. So wire concealment, even if you have to use a conduit and that conduit has to be wrapped in a veneer to match the space back, these are the things you want to do to think about concealment. Again, it may not be applicable in plenum spaces or stuff in the ceiling or stuff in the floor, but areas where wires can be visually seen, you want to consider that small c, which is part of that framework. So again, circuitry, how do we run and plan our wiring for this lighting system? And the small c, concealment, is not as big as the other ones, but there are situations where you need to conceal your wires. And so that brings us to the end of C in our ABCDE framework. Next, we're going to move on to design, detail, and dimension.